Hi, guys, and welcome back to another lesson in Math Ease with Miss C. So far, we've learned what HCF is and how to calculate it, but today we're going to take things a step further. We'll learn how to apply HCF to real life word problems. If you missed out on the previous videos about HCF, I'm sharing the link in the description box below. Make sure you check them out. So, without wasting any time, let's get started. But wait a minute.
Wait a minute!
Before we jump into the word problems, let's first understand when we actually use HCF in real life. We know that it's a HCF problem when something has to be divided into equal parts, or when we need to make groups or distribute something equally, or if we want to find the biggest size that can fit exactly into two or more things. Whenever you see a problem that talks about equal division, grouping, or largest possible size, that's your clue. It's a HCF problem. And now let's solve our first word problem together. A merchant has 120 and 180 liters of two kinds of oil. He wants to sell the oil by filling both kinds into tins of equal volumes. What is the greatest volume a tin can have? Now, if you remember the first point we mentioned before, dividing something into equal parts, you know this problem fits that description perfectly. We are dividing the oil into equal parts and finding the greatest volume a tin can have. The word greatest is a hint in itself. This means we need to find the HCF of 120 and 180. Let's begin by writing down both 120 and 180 like we always do. We make the lines that we use for prime factorization. Now, let's divide them by 2 since they're both even. So 120 divided by 2 is 60 and 180 divided by 2 is 90. We have even numbers again, which means it's time to divide them by 2 again. So 60 divided by 2 gives us 30, and 90 divided by 2 gives us 45. So now, since both numbers can't be divided by 2, we're going to try dividing it by the next prime number, which is 3. And yeah, both 30 and 45 can be divided by 3. So 30 divided by 3 gives us 10, and 45 divided by 3 gives us 15. If we try to divide them by 3 again, we'll notice that even though 15 can be divided by 3, 10 can't. So we stop using 3 now and move on to the next prime number, which is 5. Both 10 and 15 can be divided by 5. So 10 divided by 5 gives us 2, and 15 divided by 5 gives us 3. It's time to stop right here, since 2 and 3 can't be divided by prime numbers anymore. Why is that? Because they're both prime numbers themselves. I hope you all remember what we have to do next. We multiply all the numbers on the left. So that's 2, 2, 3, and 5. So we are going to write that the HCF is equal to 2 times 2 times 3 times 5, which is 60. This is the HCF, which is our final answer. So the greatest volume tin the merchant can have is actually 60 liters. Let's try a different question now. But this time we're going to go for one that explains the last point that I mentioned in that list of 3 points, which was the biggest size that can fit exactly into 2 or more things. Okay, so here we go. A school has 2 rectangular playgrounds. One is 84 meters long and the other is 108 meters long. The principal wants to divide both playgrounds into square plots of the largest possible size so that no space is left over. What should be the side length of each square plot? Did you notice how the key phrase here was the largest possible size that fits exactly? That's your hint that the problem is about HCF. The words largest and fits gives it away. Now, back to the first step, writing the numbers down, which is 84, 108. And we make the lines like we always do. So, since both the numbers are even, we're going to divide them by 2. 84 divided by 2 gives us 42. And 108 divided by 2 gives us 54. Both numbers are even again, so let's divide them by 2 again. 42 divided by 2 gives us 21, and 54 divided by 2 gives us 27. Now, both of these numbers are odd, but luckily, even though they can't be divided by 2, they can be divided by 3. So 21 divided by 3 gives us 7, and 27 divided by 3 gives us 9. Now we have to stop here because even though 9 can be divided by 3, 7 can't. And unless both numbers are divisible by the same prime number, we have to stop. So now you know the drill. Time to multiply the numbers on the left. So the HCF is equal to 2 times 2 times 3, which gives us 12. So our final answer is 12, meaning that the side length of each square plot should be 12 meters. Now, don't think I'm going to let you off the hook so easily. Now it's your turn. A tailor has 2 rolls of cloth. One roll is 90 meters and the other is 150 meters long. He wants to cut both rolls into pieces of the largest possible equal length without wasting any cloth. Write your answers in the comments below and let's see how many of you get it right. And don't worry if you don't. I'm always here to help you out. If you enjoyed this video, hit the like button, share it with your friends, and subscribe to the channel for more math lessons that are going to make math class very easy. That's all for today. Remember, don't hate math, keep practicing, and I'll see you in the next video. Bye!